Okay, sir, today we are from group 8. We are going to present about our project, which is 2JZ GTE Engine. And here is the list of our group member from group 8. Okay, let's move to the part of introduction. Since we know that our engine is 2JZ GTE engine, here we want to focus more about the piston, since piston commonly used for many different type of engine. Okay, now we moving to objective part, since we want to focus more about the piston. So the first one is we want to do a structural analysis of the piston, and the second one is we want to do a finite element analysis of the piston, and the third one is we want to analyze the stress within the various part of the piston, and the last one is we want to analyze the thermal and mechanical stress from for the real part of the engine piston.
Greetings, my name is Ahmad Fazrin bin Mat Johan and my matrix number is MH19074. So in this video, I will be explaining about the literature review of this engine report. So a reciprocating engine is a famous type of engine that uses one or more pistons to transform the thermal energy of the fuel into rotary motion. It is known as a reciprocating engine because of the pistons reciprocating to backward and forward motion that generates the mechanical power required to complete the task. A reciprocating engine is also known as a piston engine because it uses a piston. It works on a basic principle of converting chemical power, that's fuel, into mechanical energy, the rotary motions, and it have one or more pistons which available in 2 strokes and 4 strokes cycle. So the cycle is first intake, and the second one is compression, the third one is power, the combustion, and last cycle is exhaust. So this transformation happen inside the engine cylinder during the combustion process. The piston is the most major and important component inside the engine that has a circular shape. It reciprocates inside the cylinder. The downward and upward movement of the pistons helps the engine to suck and compress the fuel. The piston is directly connected with the crankshaft, and it transfers its rotary motion to the crankshaft via connecting rod. In this report, our group looking at the thermal stress analysis on the piston head. The analysis was carried out using the finite element method. This engineering analysis is a process of the determining the functionality of the design object, the pistons. So we use Autodesk Inventor Nastran software for the analysis stress load with consideration of the thermal heat transfer. Consider the thermal expansion and how it affects products being analysis. There are different approaches in performing the thermal stresses analysis. The approaches depends on the temperature distribution that cause the thermal expansion, also known as a thermal strain.
Okay, now let's move to the methodology part. Since I said in introduction part, we had using 2 software. The first one is Autodesk Nastran and the second one is SolidWorks. So since this project is created from early of the semester, so we start with the literature review of the engine, and then we do some discussion and research more about this engine. After that, we can continue for the 3D modeling by using SolidWorks, and after we obtain the design, so we can transfer it to another file and open in Nastran analysis, so we can do stress analysis there. After we run a few tests, if we fail, we need to restart again and edit the model. So after a few time we obtain that we want, we can proceed with the result and the discussion. So that's all the process within this project.
So greetings, doctor. So my name is Sivraj Malakiravi, metric number MH19079. So now we will go through with the simulation results. So firstly, we use the inventor Nastran to even model the piston. Actually, since I don't have the SolidWorks application, so I couldn't model it in the SolidWorks, but I extracted a SolidWorks model and then I redesigned it using Inventor Autodesk Inventor, and then I design it according to this type of sample. So the with exact similar bore diameter, and then the same material is applied to the piston, and also with a similar type of design at the piston head. So now we will move to the next part, was doing meshing. So I applied meshing through the Inventor Nastran, and then I applied the load of 9,455 Newton and pressure at 81 atm, which actually we got it from our previous assignment for engine calculation of 2JZ GTE Toyota Supra engine. So from here, and also from the graph, we got it the pressure. So I applied that to the inventor Nastran for the analysis, and then this is the results from the thermal and static analysis. So from the thermal, we can notice that the temperature reached maximum to 1597 from the workload force applied. So this means that for a certain RPM, when it happens repeatedly, this is the maximum amount of temperature it can reach. And then we can notice that the corner part is still blue, which means it's still under control. Not It's still hot, but not too much hot, where the top part is already starting to heat up for this type of material, aluminium, forged aluminium. And for static analysis, we can see if the piston is put into static with this kind of load, it might go bend like this. So the data of heat is happen with growth by distance, so the heat dissipates actually. So that's why the graph is like this. And then following that, the summary is the stress and this comes under a static analysis of inventor Nastran simulation. We found that 3.855 to the power of 7 of force is applied on the piston, so until the piston can bend. So, and also the temperature is the maximum of 1597 degrees during this amount of maximum load applied to that current of piston. So next we will continue with the calculations.
To our lecturer, Dr. Devarajan. My name is Kavin and my matrix number is MH18052. Today I am going to present on the kinematics calculation. So for the crank radius, the formula is piston stroke divided by 2 and the value that we obtain is 43 millimeters. So for the frequency, the value that we obtain is 0.010714. As for the angular velocity, the value that we obtain is 0.067318 radian per second. So for the piston position, we can assume that the crank radius and crank angle to be 43 millimeters and 75 degree. So the value that we obtain for piston position is 0.0116. As for the piston velocity, the value that we obtain is negative 0.0303. As for the piston acceleration, the formula is as shown in the slide. That's all from me and thank you.
For my part, I will explain about the kinematic calculation, the formula that involved in the kinematic calculation, and the conclusion. First, we go to this figure. This figure shows the crank slider mechanism and the single cylinder internal combustion engine component. An internal combustion engine is a type of heat engine that transfers the chemical energy from fuel into the mechanical energy to the crank slider mechanism, a fundamental component of an internal combustion engine. The fuel is burned in the combustion chamber during the combustion process. The piston is pushed along the negative x-axis by the combustion process, which boosts the gas temperature and the pressure. Crank slider mechanism is comprised of a race pin connected rod, front pin, crank, and the main pin convert linear action into the rotating motion. The torque generated by the crank rotation motion is used to propel car to or other equipment. So this is the formula that involved in the kinematic calculation. We have to find and theta instantaneous piston, carrying volume, displacement volume, BD, compression ratio, RC, displacement volume, BC, and for BD also we have to calculate this all is the formula that involved in the kinematic calculation. And the last part is the conclusion. Throughout our journey, we ran into the several difficulties determining which motor and the cylinder to use, but in the end, we solved the problem and chose the 2JZ GTE engine that power of the Toyota Supra RZ. Throughout to the course of this project, we learned how to use the SolidWorks program to model our piston head, the invented Nastran analysis software program to run our piston head examination, and finally with the program in expectation that was given to us by our speaker to run the investigation into the cylinder conduct during the motor running procedure. To sum up, our finding from this study, we discovered that our cylinder may have an actual issue regarding its durability throughout the control stroke process, where it has a fragile spot that might affect the cylinder head quality and lead to piston rupture. As a result, we recognize that the piston design we picked is not suitable for the long-term use. Thank you.